In August 2006, the International Astronomical Union gathered for a historic vote, one that would forever change our understanding of the solar system. The subject of this momentous decision was Pluto, the ninth and most distant world from our sun, a tiny, icy body orbiting at the edge of our solar neighborhood. For over 70 years, Pluto was part of the planetary family, featured in textbooks, models, and the imaginations of generations who learned to recite the names of 9 planets. But on that day, astronomers made a controversial decision. Pluto was demoted, its planetary status revoked after much debate and careful consideration. It was no longer a planet, but instead reclassified as a dwarf planet, a new category that reflected its unique characteristics. The decision sent shockwaves across the world. People were upset. They'd grown up with 9 planets, and suddenly there were only 8. The news felt personal, as if a member of the cosmic family had been cast out. Pluto became a symbol of the underdog, the outcast at the edge of our solar system, inspiring sympathy and even a sense of injustice among the public. The public reaction was passionate, protests erupted, petitions circulated, and even songs were written in Pluto's defense. People rallied to bring Pluto back, showing how deeply science can touch our emotions. But for astronomers, this was about scientific consistency, not emotion. Their goal was to create a definition that could stand up to new discoveries and future challenges. Science refines our understanding as new discoveries challenge old ideas. It's a process of constant questioning and revision, not a collection of unchanging facts. The decision to reclassify Pluto was years in the making, driven by discoveries of other small, icy worlds in the Kuiper belt that forced astronomers to ask a tough question. What is a planet really? The solar system was more crowded and complex than we'd imagined, filled with countless objects beyond Neptune, and our language had to catch up to this new reality. Pluto's fall is a lesson in how science works, not as a set of permanent truths, but as a dynamic conversation that evolves with evidence and discovery. Sometimes, cherished ideas must be let go for a more accurate view of reality, even if it means rewriting what we thought we knew. The controversy wasn't just about Pluto. It was about how we organize our knowledge of the cosmos and how we adapt to new information. It forced us to reconsider the very words we use to describe our place in the universe and to accept that definitions can change as our understanding grows. And the debate continues to this day, reminding us that science is always moving forward and our story of the solar system is still being written. To truly understand Pluto's fate, we need to look back in time and trace the fascinating journey of how we've defined planets throughout history. The word planet comes from the ancient Greeks, meaning wanderer. These mysterious wanderers captured the imagination of early astronomers. They noticed a handful of bright points of light that moved against the backdrop of fixed stars: Mercury, Venus, Mars, Jupiter, and Saturn, along with the Sun and Moon, all seen as celestial wanderers. Earth wasn't on the list. It was believed to be the stationary center of everything, unmoving and unique in the cosmos. This geocentric view dominated for centuries, lasting until the revolutionary ideas of the 16th century. Then, Copernicus proposed a radical idea, that Earth and the other planets revolved around the Sun, not the other way around. The Sun became the center, the Moon was reclassified as a satellite, and for the first time, Earth was promoted to the status of a planet. The definition of a planet shifted. Now it was a world that orbits the Sun, a major change in our cosmic perspective. In 1781, William Herschel discovered Uranus, the 7th planet, expanding our solar system's known boundaries. The solar system grew even larger, but in 1801, Giuseppe Piazzi found Ceres between Mars and Jupiter, sparking excitement and curiosity. Ceres was briefly celebrated as the 8th planet, but soon, astronomers found more objects in that same region. Soon, Pallas, Juno, and Vesta were discovered, each adding to the growing list of new worlds. The list of planets ballooned rapidly, but these new objects were much smaller than the others, raising questions about what truly counts as a planet. Astronomers responded by creating a new category, asteroids, and Ceres was demoted from planet to asteroid. This marked the first time in history that a planet lost its status, setting a powerful precedent. The precedent was set. As our knowledge grows, so do our definitions. The story of what makes a planet is always evolving. The story of Ceres would echo nearly 2 centuries later with Pluto, as astronomers face similar questions about classification. Our understanding of what makes a planet has always evolved, and it still does, as we continue to explore and redefine our place in the universe. For most of the 20th century, the solar system seemed settled, its structure well understood, and its boundaries clearly defined. There were 8 planets, each following their own path around the Sun, plus the asteroid belt, a band of rocky debris between Mars and Jupiter. In 1930, a young astronomer named Clyde Tombaugh made a historic discovery: Pluto, which was quickly hailed as the 9th planet, capturing the imagination of the world. But Pluto was always an oddball, tiny, with an elliptical, tilted orbit that even crossed Neptune's path, unlike any other planet we knew. For decades, Pluto reigned as the king of the cosmic frontier, the mysterious outpost at the edge of our solar system. That all changed in the 1990s, when astronomers, using powerful new telescopes, began to find more objects lurking beyond Neptune. They discovered the Kuiper belt, a vast icy region filled with countless pieces of frozen debris stretching far beyond the known planets. Suddenly, Pluto was just the first and largest of many icy bodies, no longer alone in the darkness. Soon, astronomers found worlds like Kuiper, Sedna, and Orcus, icy spheres hundreds of miles across, each with their own unique orbits. Pluto started to look less like a lone planet and more like the biggest member of a new family of distant icy worlds. The parallel to Ceres in the asteroid belt was clear. Just as Ceres was the largest of many asteroids, Pluto was now one among many in the Kuiper belt. In 2005, Mike Brown's team discovered Eris, an object as big as Pluto, orbiting even farther from the Sun. If Pluto was a planet, then Eris had to be one too, raising big questions about what truly defines a planet. Suddenly, we face the prospect of dozens, maybe even hundreds of new planets in our solar system. Astronomers could no longer avoid the question, what is a planet and where do we draw the line? The time had come for a new definition, one that could make sense of this crowded, icy frontier. The solar system was far more complicated, dynamic, and mysterious than we had ever imagined. The discovery of Eris forced astronomers to act. At the 2006 IAU meeting, 2 camps emerged. Geophysicists argued a planet should be defined by its shape. If it's round, it's a planet. This would include Pluto, Eris, Ceres, and even some large moons. The geophysical definition is simple. If gravity makes you round, you're a planet. The other camp, the dynamists, focused on gravitational dominance. A true planet, they said, must clear its orbital neighborhood. The 8 major planets have done this. They're the gravitational rulers of their zones. Under this definition, Pluto, Eris, and Ceres don't qualify. They share their orbits with many other objects. The dynamical definition keeps the planet list at 8. The debate was about what matters more, an object's nature or its role in the solar system. Both sides had strong arguments, but only one definition could win. The fate of Pluto hung in the balance. The debate in Prague was intense. After much discussion, astronomers voted on a new definition of planet. The resolution combined both perspectives, but ultimately favored the dynamical view. To be a planet, an object must meet 3 criteria: orbit the Sun, be nearly round, and clear its neighborhood. The first 2 were easy for Pluto. It orbits the Sun and is round. But the third was the deal breaker. Pluto's orbit is crowded with thousands of icy bodies in the Kuiper belt. It hasn't cleared its neighborhood. Because of this, Pluto failed the test. The IAU voted to reclassify Pluto. It was no longer a planet. A new category was created for it. The solar system's official planet count dropped to 8. The decision was controversial, but it brought clarity, at least for a while. The definition was set, but the debate was far from over. Pluto's story had entered a new chapter. Pluto became the prototype for a new category dwarf planet. A dwarf planet orbits the Sun and is round, but hasn't cleared its neighborhood. The term was meant as a compromise, but it caused confusion. In astronomy, dwarf usually means a smaller type of something, like dwarf stars or dwarf galaxies. But a dwarf planet by IAU rules is not a planet at all. The classification system now includes planets, dwarf planets, and small solar system bodies. The lines are blurry, and the debate over labels continues. Years later, the Pluto debate rages on. Many planetary scientists reject the IAU's definition, arguing that Pluto's geology and atmosphere make it a planet. They point out that the clearing the orbit rule depends on location. Move Earth to the Kuiper belt, and it wouldn't qualify as a planet either. The New Horizons mission revealed Pluto as a dynamic, complex world. For many, that's proof enough. The debate highlights a deeper question. Should classification be about exclusivity or about grouping similar worlds? The answer remains unsettled. The Pluto problem is really about classification. Humans love to categorize, but nature doesn't always fit our boxes. The solar system is full of variety: gas giants, rocky planets, icy worlds, asteroids, comets. Drawing sharp lines is hard. Nature is more creative than our labels. The IAU's definition prioritizes gravitational influence, but another group could have chosen geology. Neither is absolutely right or wrong. They're just tools for understanding. The debate is about which tool best helps us understand planetary formation and evolution. Our definitions are human inventions, not cosmic truths. Pluto continues its journey, indifferent to our debates. The real challenge is building a system flexible enough for the universe's diversity. As we explore, our categories will keep evolving. The universe doesn't care about our labels, but we do, because we're always searching for meaning. Pluto's story is a lesson in the scientific process. Science isn't a static list of facts. It's a quest for knowledge that changes with new discoveries. The demotion of Pluto wasn't a failure. It was science working as it should. As we find new worlds, our definitions must adapt. The 9-planet solar system was a cultural fixture, but science moves forward. Each discovery tests our understanding and forces us to refine it. The classification system will keep changing as we learn more. The Pluto debate reminds us to stay humble and flexible. Whether you call Pluto a planet or not, the conversation is what matters. In questioning and debating, we find the true spirit of science.